So for the first one, he is correct in that that is not a linear equation because x and y are being multiplied. And so the way that I describe whether or not something is going to end up being linear to students is if there's something funky happening to y, like it's being squared or square root or something like that, then it is not going to be linear. So in the case of something being linear, we will just have a y by itself with nothing else. And so in the case that we have xy on the first one, that is going to be not linear. That would actually be parabolic. And the second one, it looks like you set that up correctly. I'm going to run through the math. So the standard form of things is ax plus by equals c. And so I'll talk about that as we go through it. So we need an x term first, a y term second, and then a constant on the other side of the equal sign. And so our goal is to cluster the x's on the left, so we will do that. So plus 4x plus 4x, we will get 12x minus 3y equals 6. And so that fits ax plus by equals c now. The next piece of this, determining the x and y intercepts, involves a little bit more work. And so the x-intercept will happen when the y value is 0, and the y-intercept will happen when the x value is 0. I'm going to model that really quickly and just kind of demonstrate this. And so if we have a graph of a linear function like that, at this point, that's the x-intercept. And for that to be the x-intercept, the y value has to be 0, so that would be like something like negative 3, 0. And that second value would always be 0, because anywhere that a line intersects the x-axis, any of these points, these green dots that I'm making, all of those green dots have a y value of 0, because they do not go up or down at all. The opposite of that is true for the y-intercept. So for the y-intercept, the first value is always going to be 0. So our x value is always going to be 0. This might be 0, negative 3. And similar to the x-intercept, the y-intercept will always have an x value of 0 because anywhere that I intersect the y-axis here with these yellow points, the x value is 0 because there is no movement side to side. It's always been kind of tricky to me to deal with x and y intercepts like this because if you want an x-intercept, your y is 0. If you want a y-intercept, your x value is 0. And so they're backwards of each other. So just kind of silly and frustrating. So for the x-intercept, we are going to take our equation that we started with, and we are going to put 0 in for y. So we get 12x is equal to 6. Divided by 12, x is equal to 6 over 12, or 1/2. So the x-intercept would be at the point 1/2. The y-intercept happens when the x value is 0. So we'll put 0 in for x. And we get negative 3y is equal to 6. Divided by negative 3. And we get y equals negative 2. So the y-intercept would be at the point 0, negative 2. As you can see, this requires a lot more work than the space that is provided on the page to figure out these intercepts. So I'll leave that there. You can pause if you need to before I move on. Number 3. Again, he is correct. 7x plus y, so plus 3, is equal to y. And so nothing funky is happening to y here, but he does have them crossed off, and so what's really going on there is if we were to get this set up like ax plus by equals c, we would want the constant on the right So we would subtract 3. And then we would have 7x plus y is equal to negative 3 plus y. We would want to move that y to the left, so we would subtract y. And we are left with 7x is equal to negative 3. There is no y value, but I'm going to finish this and I'm going to demonstrate what this would be. And so if we were to say, okay, this is ax plus by equals c, doesn't look like ax plus by equals c because there is no y value. What's really happening here, if we just solve this for x, if we were to graph this, we would have a vertical line that passes across the x-axis at the point negative 3 over 7, 0. And the vertical line is linear. It's a straight line, but because its slope is what we call undefined, it is classified as being not linear, even though it does form a straight line. And so in the case of number 3, the answer is no, but this right here that I just explained is why. Again, it is a straight line, but it is not linear because its slope is undefined. It does not have a slope. Now that I say that about not having a slope, it is important to understand that a line that is horizontal is considered linear because it does have a slope. Its slope is 0. So undefined basically means its slope does not exist. If it were to be a horizontal line instead, that would be a slope of 0, which is a slope and is considered linear. So the green line would be linear, the red line, no. Again, I'll pause before I move on. Number 4, we have 5 minus 2y equals 3x. So we need to make it look like ax plus by equals c. And so we need to move that. Well, first one, we can do lots of different things. The first thing that I would choose to do is move the 5 to the right. And so I would subtract 5 from both sides. And get negative 2y is equal to 3x minus 5. Remembering we want this to look like ax plus by is equal to c. So we want our x term on the left side of the equation. So we will subtract 3x from both sides. And we will get negative 3x minus 2y is equal to negative 5. And I see the work that had been done was it looked like you were trying to put it in slope-intercept form, which would look like y equals mx plus b. And I do believe you did that correctly, but they are asking for standard form, and it's kind of silly. I hate standard form. It's sort of useless and a waste of time, but that is what we are asked to do. So now we have it in standard form, so we do need to find the x-intercept and the y-intercept. So the x-intercept and the y-intercept. Remember that the x-intercept happens when the y value is equal to 0, and the y-intercept happens when the x value is equal to 0. So we'll just copy our equation over. And so for this one, I do need to put 0 in for y. Solve this down. I assume we get to use a calculator, but just for the purpose of the rules of letting my thing disappear. That's okay. Okay. Just for the purpose of saying it, a negative divided by a negative does make a positive, so the answer here is going to be positive 5/3. So the x-intercept would happen at 5 over 3. The y-intercept happens when the x value is 0, so negative 3 times 0 minus 2y is equal to negative 5. Negative 2y is equal to negative 5. Similar to the other one, we're going to divide to isolate the variable by negative 2 in this case. Again, a negative divided by a negative makes it positive, so the y value will be positive 5 over 2. So the x-intercept would be at the point 5 over 3, 0. And the y-intercept would be at the point 0, 5 over 2. I always get confused about which one is 0, the x value or the y value, and so it's helpful, for me anyway, when I'm working on these together and say that happens when the y value is 0, and that happens when the x value is 0. And then that helps me down here to remember to make the y value 0 there, and the x value 0 there. Again, I'm not a fan of standard form, so it's sort of worthless. Number 5. Again, our goal is to make this look like ax plus by equals c. So we've got x over 4 minus y over 3 is equal to 1. And this one, there are lots of ways to tackle this, and I do not know if you have seen what I am about to show you. But I hate fractions, and so one thing I need you to understand about this, let's do something else actually. I'm going to demonstrate something that is unrelated to this problem. So over here on the right, if you look at this piece that kind of run smoothly around, that's a true statement. 5 plus 3 is equal to 4 plus 4. Because they would both be equivalent to 8, yes? And so a conversation that I like to have with students is, what would happen if I added 7 to that side? Well, that would make 15. And if I added 7 to that side, that would also make 15. Why would you add 7? You have no reason to add 7. But if I do it to both sides, it would preserve equality. They would still both be correct. If I subtracted 2 from both sides, now I would have 6 equals 6, and then still be equivalent. And so the reason I bring this up is for what I'm about to do to make sense, you need to understand that I can do whatever I want to an equation as long as I do it to both sides. So I'm going to be intentional about what I do to this equation for number 5 because I hate fractions and I want them to go away. So I am going to multiply both sides by 12. Because 12 has the factors 4 and 3. So by multiplying both sides by 12, the fractions are going to divide out. And I will demonstrate that for you right now. So distributive property on the left gives me 12x over 4 minus 12y over 3. And then 1 times 12 is 12. Now if we look at 12x over 4, 12 divided by 4 is 3. And the same thing with 12 divided by 3 is going to be 4y equals 12. Now we're dealing with only whole numbers, and life is good. And that looks like ax plus by equals c now. So, the work that we have to do at this point, we do have a linear function, is to find our x-intercept. That happens when y is 0. And our y-intercept. That happens when x is 0. So 3x minus 4y equals 12. We would have a y value of 0 here, so 3x minus 4 times 0 equals 12. 3x is equal to 12. Divide both sides by 3. X is equal to 4. So again, remembering the y value is 0, so our x-intercept would be 4, 0. Then over there, our x value needs to be 0. Negative 4y is equal divide by negative 1. And y is equal to negative 3. So our y-intercept would be 0, negative 3. And this trick that I showed you here with fractions, this will work every single time you have an equation that has fractions in it. You just need to multiply by a number that is divisible by both denominators, and you'll end up with whole numbers like I did. So number 6, we're going to do number 6 looks white. So I'm actually going to pause here, give you time to pause if you need to before I move on. And I may need to take some time to think before I tackle number 6, because off the top of my head I'm not sure how to approach that one. Okay, so for number 6, it goes back to what I've mentioned before, that if something goofy is happening to y, it is not going to be a linear function. So 5 over x minus 2 over y equals 7. Because y is being held in the denominator there, that is going to mean that this function is not linear. It would actually, I think it would be parabolic. It's a hyperbola with this one. And so 6 is simply not linear, we don't need to do any work around it. So again, just kind of remembering if something goofy is happening to y, it's not going to be linear. And it looks like for number 5 you did try to put that in slope-intercept form. I'm not sure if that was done correctly or not, but going back to number 5, we should end up with, there must have been something goofy. I will put number 5 in slope-intercept form because it looks like you attempted to do that. Or was that for number 8? I can't tell where that word came from. But if you were to put number 5 in slope-intercept form, it would not be the 3 over 2x plus 2.5. So, I'm not going to do that after all. Number 6, again, not linear. Number 7, need to graph each function. I cannot see what that says in the screen up there. If you're trying to graph something, just having a 3x5 card in your hands is often helpful. Is a negative. Okay, so for graphing each equation, I cannot tell what that number is right there. I will walk you through how to do the rest again. So graphing these again, I think standard form is kind of junk, and so I'm actually going to skip to number 8 because I'm not sure what that number is on number 7. But for number 8, what we want to do is go ahead and put these in slope-intercept form. Or there's 2 ways to do it, and I will demonstrate both. You can do this using x and y intercepts, and you can do this using slope-intercept form. My personal preference would be to just convert this to slope-intercept form because it's easier and makes sense to me. The downside of that is that it doesn't work well when you end up with y-intercepts that are not whole numbers. And so this one is going to end up that way, and so I will demonstrate why putting this in slope-intercept form is not going to work in this instance. And so we would subtract 5x from both sides. We would have negative 2y is equal to negative 5x plus 7. Then we would divide by negative 2. And we would have y is equal to positive 5 over 2x minus 3.5. And I'm actually never going to write something like that as a decimal. I'm always going to leave it as a fraction, so that is going to stay as negative 7 over 2, which again is equivalent to negative 3.5. Whoever is teaching this class or any math class in your life is not going to allow you to graph a y-intercept that is not a whole number, like negative 3.5. And so this is not something that we can effectively graph because our graph goes by whole numbers, not by halves. And so the alternative way to graph that is to use the x-intercept and the y-intercept. And so again, the x-intercept happens when y is equal to 0, the y-intercept happens when x is equal to 0. And so what we would do is take 5x minus 2y equals 7. And for the x-intercept, put 0 in for y. It's going to come out like garbage also. So that's kind of nasty. So we would divide by 5 and we would have whoever wrote these problems did a terrible job. So we would have x is equal to 7 over 5, which would mean that our x-intercept would be 7 over 5 is 0, which comes out to be a fraction anyway, so we might as well have used the y-intercept in the first place. The slope-intercept form in the first place. We could use that, or we could use these two intercepts to figure it out, which I'll also demonstrate that in a moment. So 5 times 0 minus 2y equals 7. Negative 2y is equal to 7. Sometimes I think people that write math books just need to be slapped, so this is a ridiculous problem. So y equals negative 7 over 2. There is no reason for these not to be coming out as whole numbers, because how are you supposed to graph that on the graph that only has the number of values? So, the way that I would handle this personally, I just pulled up some graphs, and don't pay any attention to these equations that are on here. I'm just using it so that I would have a good available. And so going back to that briefly, we have an x-intercept of 7 over 5, which is just terrible. I don't know how they expect you to graph that. Or I could use the slope-intercept form and do 5 over 2x minus 7 over 2. Any method of this is going to end up with a graph that is not accurate because we can't judge those values correctly. So negative 7 over 2 is negative 3.5, and then up 5 to the right. So my best guess with this one would be the slope-intercept form would be negative 3.5, up 5, 1, 2, 3, 4, 5 to the right 2. And then 1, 2, 3, 4, 5 on the room. So we'd end up doing something. Again, I do not know how they expect you to do that on the graph paper, but it is provided there. That's ridiculous. So, the next one, number 9. We have 1.5x. Plus 3y equals 9. And then we can attack this one using the same methods that we did above. I will do both. I will put it in slope-intercept form, and I will find the x and y intercepts. Maybe before I do number 9, we should look at the graph at number 8 and see what our x and y intercepts look like. So it looks like our x-intercept would be about negative 3.5, or sorry, our y-intercept would be about negative 3.5, and our y-intercept would be about 1.5. Sorry, our y-intercept would be about negative 3.5, and our x-intercept would be about 1.5. That's what we have here. Y-intercept of negative 3.5, x-intercept of about 1.5. That looks like it would have matched. Again, I think that having these as fractions is ridiculous. So The other piece, again, I never allowed decimals in equations like this, so I'm actually, for my own purposes, going to convert that decimal later. But let's go ahead and solve for y, so we can have this in slope-intercept form. We would have 3y is equal to negative 1.5x plus 9. We need to divide by 3. And we would have y is equal to negative 1.5 divided by 3. We'll go my calculator. It's 0.5. So I'm going to leave that as negative 1/2 x plus 3. This one we should be able to graph this one pretty easily from that information. I am still going to do the x and y intercept just to show how to do that. So the x intercept then happens when y is equal to 0. Y intercept happens when x is equal to 0. So 1.5x plus 3y is 9. 1.5x plus 3y equals 9. And put a 0 in for the y, we get 1.5x plus 3 times 0 is equal to 9. 1.5x equals 9 divided by 1.5. And we get x is equal to 4. So our x-intercept would be at 4, 0. Putting 0 in for x. We would get 3y equals 9 divided by 3. And we would have y is equal to 3. So our y-intercept would be at 0. And so the 0, 3 matches what we have over here for our y-intercept of 3. So either one of these methods will work to graph it. What they're probably trying to push you to do in this particular set of problems is to graph using the x and y intercepts. That's what my guess would be. Again, here you have a fractional slope of negative 1/2, which is not bad. But I will demonstrate both methods of graphing this. And so we bounce over the graph. So I will graph these side by each, one using the slope-intercept form and the other one using intercepts. So using slope-intercept form, we would have y is equal to negative 1/2 x plus 3. We would start at 3, we would go down 1 to the right 2. Repeatedly, or up 1 and to the left 2 repeatedly. We have a graph that does this. And we need to check, I need to do some work and check my x-intercept section. My x-intercept because it looks like the x-intercept should be 6. That is correct. So I made an arithmetic error here. I should have used a calculator. 9 divided by 1.5 is not 4. 9 divided by 1.5 is 6. So our x-intercept would actually be 6, 0, not 4, 0. Apologies. So, coming back here, I used the slope-intercept form to graph that. Alternatively, we can use the x and y intercepts. So the x-intercept is going to be 6, 0 over there, and the y-intercept is going to be 0, 3 right there. And if we were to use those to do this, we would not be given the slopes. We would not know that it was negative 1 over 2. But we could graph it by simply using those two intercepts, and it would look exactly the same as if we used slope-intercept form. Again, I'm a much bigger fan of slope-intercept form than I am of standard form, and I think that it's much more useful. Again, number 8 is it's silly to try to ask someone to graph something like that, especially on that graph that's provided there. And if you need to have it number 7, just text me what that missing number is there, and I'll